Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signals and Systems Analysis. We will continue our discussion on time domain analysis of continuous system. In the previous video, we have discussed system response and also zero input response, and I have also shown you a few examples on how to determine the zero input response of a linear differential system. So in this video, we will continue our discussion on impulse response. Let me just change to laser pointer first. Okay. So impulse response refers to the output of the linear differential system when the external input of type impulse is applied. So if you have your block diagram like this, okay, where you have your box here, which is your system. Okay, so the output here is an impulse response. Okay, if you have an input of a unit impulse over here. Okay, so the mathematical representation is given here. So let's say we assume that we have a linear differential system that is represented by this equation over here. So I think if you have seen my previous video on zero input response, you will be familiar with this equation. Okay, except there is a small changes over here, where instead of bm minus n, here we have bo, b1 until bm. So again, the polynomial over here can be represented by qd, and the polynomial over here can be represented by pd. So this equation over here can be rewritten as shown over here. Okay. So once we get this equation, we can get the general solution of the unit impulse response, okay, given by the equation over here, where here you have bo, this is the impulse, okay, sigma, plus pd ynt u of t. This bo is the multiplier of the highest order of the derivative of the input signal. So this yn of t is a linear combination of the characteristic mode and subjected to the following initial conditions. Okay, if n equals to 1, then you have yn 0 equals to 1. So this n here is the highest order of the derivative of the output, okay, in the linear differential equation. Okay, this n over here. So if you have a derivative to the power of 5, so you have a fifth order system, so your n is 5. But like I said in the previous video, in our course, we will only look at second order system, the highest order, the second order system. So n equals to 2. So in order to understand the equations that I have shown in the previous slide, I give you here 3 sample problems that we can solve, okay, in order to determine the impulse response of the given system. Okay. So I will see you in the next video, where I will show you the solution to these sample problems. Thank you.